Chandrakant sir, I think we can start.
Okay, we can start. Hope I'm
Yes,
audible.
yes, sir.
Yes, okay. So we'll start. Good afternoon, ladies and gentlemen. I'm Chandrakant from EDS Technologies, and I'll be your host for today's webinar. First and foremost, we thank each and every one of you for taking your time and joining this webinar on enhanced collaboration with OEMs, suppliers, and deliver accurate 3D models. I would like to begin webinar by giving a short introduction about our company. Yes.
Chandrakant sir, you're muted. Sorry.
Yeah, thank you. So ADS Technologies was incorporated in 1994 to focus on providing PLM solutions, implementation and support. We are largest technology solution providers in India and also platinum partner to Dassault Systems. We have served more than 2,000 customers across India and operate in around 9 locations across India with our headquarters in Bengaluru. We have strategic partners with world leaders like EOS for additive manufacturing requirements, human solutions for ergonomic solutions for automotive and aerospace industries, typically Technia for ensuring product data quality. For military simulations and training needs of aerospace and defense industry, we have partnered with MAC for visual simulation solutions. We also have strategic partnership with ESRI for any GIS requirements. With respect to EDA solutions, we closely work with Synopsys also. So we have dedicated sales, support, marketing, customer satisfaction teams to address customers' PLM business and support requirements altogether. In today's webinar, we are joined by Mr. Sushil and Mr. Nagappa. Mr. Sushil has more than 20 years of experience in automotive engineering design and development. He has worked with major automotive OEMs in India and in Europe like Tata Motors, M&M, FCA, Volvo Cars, McLaren, to name a few. He specializes in BIW design and development, composites, carbon fiber, BIW design, automotive ergonomics, occupant packaging. He is currently working as a senior solution consultant at EDS Technologies for QChecker, Ramsys, Kava, and other allied solutions. Our second speaker is Mr. Nagappa. Mr. Nagappa has more than 7 years of experience in multiple domains such as product development, technical support, functional consultants, and technical documentation. He specializes in CAD, product lifecycle management solutions. He has various global certifications from Dassault System also done by him. He is associated with EDS Technologies as senior application engineer and supports various other customers. So before we begin our seminar, I would like to inform you that we shall be taking up Q&A sessions after delivery of the webinar. We shall also be accepting queries through question box, which also be addressed in post webinar. So we would like to take it up from here. Over to you, Sushil. You are not audible, Sushil.
Yeah, thank you. Thanks a lot for introduction and the topic of today's discussion. So good afternoon, ladies and gentlemen. We start from here our topic. This is product data quality. It's a measure of accuracy and appropriateness of the product data and the timeliness delivery of the data across the line and down the line users. So what we really mean is from that is we have to deliver good product data quality to providing right quality data to the right people at the right time, and thereby saving a lot of time, cost, and efforts of the included people. So, and this is all we do for a purpose, of course, we know, thereby to remain sustainable in the business and make profits in the business. With this, we go to the next slide. here this slide is, for example, taken for the automotive product development, for example, a passenger car, but it can be any product, small or big. The philosophy of the product development remains same. We start with a concept and we go up to the production in the intermediate phases like engineering, analysis, and manufacturing. So the data starts with the very first, like in the concept phase, and it ends up to the production phase. So if we have the right data right in the concept, it can solve a lot of future issues in the in terms of quality and the cost included. Now, in industry, we always say that CAD is a master. It's a buzzword. Like everyone talks about CAD, and CAD is a master, and it's like a single language spoken in any industry. So why it is important is it's at the center point of all the activities, and a lot of other peripheral teams that concurrently work on the data. So maybe the data released can be used for by tool makers for making their tools. For prototyping, team can make use of the tools. For tolerancing team, they can make use of the tools. But imagine a condition if the data is not right quality, then these all stakeholders will have their actions or activities stopped due to the absence of quality data. So the requirement of quality data starts in the very beginning of the product, and it ends with the product life cycle. Let's take a small example here, a very classic example, how the product data quality start deteriorating in the very first phases. Now, imagine we have a imported curve. Maybe you can consider a door shut line in the car or something like that, and it has some connectivity issue here, like tangency or curvature connectivity, and we didn't notice it. We start engineering the components based on this curve. We make surface out of it. Then we do a lot of surface operations. We make a like a trim or maybe final output of the surface. Then we have another the final output that can be thickened, and we make a final product out of it, which is the final CAD delivery from an engineer. So what will happen is, if this is not noticed in the very beginning, it can be noticed by the tool maker, who will make a tool out of it, and he will do some tool path generations and machining operations, machining programming, and there he will notice some discontinuity here. So he will ask the designer to rectify this discontinuity and re-release the data. So there are some time associated with it, like to repair. If it has been noticed in the very beginning, it could have taken just 1 minute to repair it. If it could have been noticed in the surface level, it could have taken 5 minutes to repair it. But if it takes, if it notice at the tool level, manufacturing level, then it takes weeks and weeks and months to rectify the data due to this huge involvement of the process. And it is just one part. Imagine it's a number of parts put together. So you can imagine the time and cost involved in rectifying the product due to the faulty model. There are some we do manual checking as of now in the industry. So this is the way we check our data in the industry nowadays. Like we have a release checklist, we have a delivery checklist, and we have a drawing checklist. But there are some issues associated with it. Like it is a completely manual checking process. It's a repetitive, it's a monotonous. Then it takes a lot of designer's time, which otherwise he could spend on the actual CAD work, CAD design work, and focus on the real work. So this is actually is a do and check method, which is a reactive method of doing CAD modeling. However, we should go for check while doing method, which is a proactive method of modeling. And QChecker helps in achieving this check while doing methodology. Many designers who are freshly inducted in the company may not be aware of any such tools that are available, so they can make fresh mistakes while CAD modeling. And of course, as you know, during the release pressures, we always say that there is no time for PDQ. We have to just do our work. So that's another excuse like that. But what we can do, what can be implemented is, we can take all this and make a company internal standard and have this standard implemented in QChecker together. So if there is a standard that can be implemented right in the QChecker, and there are some checklists also available that also can be parallelly built in the QChecker as a number of checks. So the CAD design quality ensure the CAD design quality during CAD modeling itself and not check afterwards. So that's the proactive way of doing CAD modeling. And there are around 400 checks in QChecker written by expert CATIA team within Technia team. Yeah, let's take some case sample studies from industry, real life examples. Understand there is a check in the QChecker that checks if there is a specific parameter available or not. And if it is not there, it can give it as an error. So, for example, if you give this parameter paint offset value, suppose any paint is around 300 millimeter, the 300 microns thick paint thickness on the body. So you can limit that value here, and what will happen is the paint shop engineer or the paint engineer who will do the costing calculations out of paint, he will be able to know the paint quantity and paint weight that will be going onto the body and the cost associated with it. But imagine if this parameter is not there and QChecker doesn't check it, then there is no chance to know the paint weight and the cost associated with it. So we can implement such very advanced level checks with QChecker, that it checks if certain parameters are available or not. So this is just one example of it, which we have faced in the industry. Otherwise, what the other way of doing it is that the paint shop engineer has to open the data, measure all the surface areas, measure offset it by the 300 microns, and then thick it and measure the volume of it. So that's a very cumbersome process, but you can just do it with the help of one parameter. Similar is here, like many companies have internal standards for material library. They don't use standard CATIA library. So if we have a check for the material, parameter for the material, then we can, these all teams can be happy. The CAE team can run their own scripts in the preprocessor and they can import the material, the data along with the material. So they don't need to import or apply another material on top of that. DME team will be very happy because suddenly management may ask them, show me the material pie chart across the body or across the product. And then if this parameter is there, within a click, that pie chart of the metals can be used, like how much percentage of the total weight is steel, how much is the aluminum, carbon fiber, or blah blah. And we can also calculate mass out of it. So this QChecker can have these kind of checks also. Another example, like ED coating, electrodeposition coating on the body, very important. It acts as a protective coating. We can have another parameter for it that can measure the surface area of the product, and by that we can calculate the total mass of the coating that will be going onto the product, or the, for example, the body here. So the simple Q checker check can be if this parameter is available or not. And if it is not there, the designer has made mistake to implement this or have this check in the CAD model, then that can be triggered as a error in the Q checker, and that can be picked and corrected. For example, there are some what PDQ constitutes is a kind of a geometry checks and methodology checks. So geometry checks in all are 20% important, but 80% importance is given to the methodology checks, what I just mentioned in the above slides. So what are the geometrical checks? Basically, these are simple checks, but very important. Position sketches, as we know, the sketches has to be position sketches, and free sketches should not be used because free sketches can turn upside down, left to right, and they can create mess with the part. We should always go for access system while creating the part because the whole part can be then derived from one single point. So QChecker can check whether it is a position sketch or not, whether the access system is given or not. It can limit the size of the model so that there is a disciplined approach of the designer. You cannot just make more and more operations and increase the part model size. Then there are checks like to hide all the points, curves, lines, planes, etc. before saving, so that our model looks clean when it is opened in the JT or some other lightweight applications. It can check whether there is any deactivated feature that the designer has left to update. and lot of datuming features, like it can check the datum sequence of the GD and T symbols also. It can check whether designer has made some mistake giving a fake dimensions. So these are all geometrical checks, but these are 20% important, but 80% importance is given to the methodology checks that I just spoken in the first couple of slides before, like paint offset parameters, surface area parameters for ED coating, weights, etc., and metal applied is correct or not. Yeah, let's move ahead. Let's check another example, a very classic example from Europe. A company in Europe had around €500,000 being spent in 1999 when they started, and then the management thought it's a very high cost, and then they implemented the product data quality philosophy in the company. They implemented QChecker in 1999, and 1 year there were no apparent gains because there were less number of users using QChecker. Not all were trained. So even in that time, the costs were too high. But as and when the number of users started increasing, more and more designers started using QChecker across the company, across all the functions. Then the repair cost started decreasing, and the maturity of the product starts gaining here. So as you see, when they ended 5-year program in 2004, they were almost 25%, almost 75% less costs were incurring on the repairs of the product, just due to the reason of bad product quality, bad product data quality rather. Some classic examples how QChecker can help you in maintain the sanity of the CAD model. For example, a company in Europe has this parameter like these all should be shown, whatever in red color and whatever in the blue should be always hidden while saving the component. It can also check where there is whether there is a publications available or not. Another like modeling methodology, like I just said before, uh, all bodies should be named. There is a check in the QChecker whether it checks that there is the bodies have been named correctly or not, or just it is body 1, body 2 is given. Because in a hurry, many designers make that mistakes. Just give the body and they don't name it. So any new designer who starts on it, he starts very fresh and he faces troubles while updating the component. So QChecker can help in this methodology check also. Let's see start with some very interesting checks what QChecker can help you in your product development and save the headache of maybe hundreds of designers at a time. Uh, if a designer does the CAD modeling, but he doesn't maintain the sanity in his checks just due to the absence of maybe right skills or maybe absence of time or maybe release pressures. So when we open this data in a lightweight application like JT, etc., then it will open like this with all of access system, a lot of surfaces shown. But QChecker can all heal this and it can make this part look like this without doing anything. Within a few minutes, maybe it can do like this. So it's a very clean model to visualize. Yeah. Another classic example that of a stamping component here, maybe some kind of spare wheel well here, which designer has very smartly. There's a folding surface here, which will never get thickened, but he has done some trick and he has thickened the component here. But and he could successfully release it in the system without knowing anybody. But when this part reaches the tool maker, there is a chance that he will completely reject this component due to the reason that this surface could not be offsetted. So you just imagine if this reaches custom tool maker and reaches back to the designer for release, it will take at least 5 to 6 weeks time to know this error and correct it. So that much time is lost in correcting the data. So we will see some one interesting slide here, how we relate the traditional methods of doing and how we do the things now. So previously we used to do a lot of 2D drawings in the 2D scenarios, and even the cars were being made that time. We used to first in the inspection scenario, we used to measure by the help of verniers and micrometers, etc. Then there were 3D coordinate dimensioning method of dimensioning the objects, which is very easy to understand, easy to explain, easy to communicate, and there were no problems here. But this is coordinate dimensioning. And then on similar lines, we have release checklist, we have CAD standards, which looks in the form of these Excel files, which each designer has to check his designs according to these checklists and verify it's correct or not. But these are old days, maybe 2-3 decades back. The business used to happen like this. But nowadays, we don't do any 2D drafting. We always go for CAD design. That's productivity improvement. Uh, Nobody now uses any physical measurement tools. We all go for gauges and CMMs and etc. etc. That's a productivity improvement. Uh, Similar like this, for coordinate dimensioning, we gone for geometric dimensioning, and we all know that geometric dimensioning has a huge benefit of almost 57% more tolerance than the coordinate dimensioning. That's the reason we get more tolerances available to play around in the geometric dimensioning. So we easily adapted this modern tool of doing engineering. On the similar lines, what we say is, what we offer our product is that we can get rid of all this manual process of doing the things here, checking, etc., and losing our time and efforts. We can just transfer all this process to QChecker and let it handle itself all the checks to perform in a short period of time, very accurately all the time, and with a lot of checks performed inside it. I hope it makes some relevance with the modern tools to increase the productivity, to save time and cost. Yeah. Let's check some standard checks what are available. However, there are around 400 checks available in QChecker, written by expert CATIA users and inside Technia team. This is a solid wall thickness check. Very important, I will say. It will give a band where the thickness is not thickness is below certain value. That value you can set in QChecker. You want it 1 millimeter, 2 millimeter. Now just imagine this is maybe a plastic component or maybe a stamping component. This is a pierced hole together, and we know that the pierced hole needs certain bridge amount here. Otherwise, the dies can crack inside. So that kind of checks can be available here. That very useful for plastic components where we have variable thicknesses, and due to certain operations, the thickness can go drastically low without the notice of designer. A very important tool. It's readily available in QChecker that can be checked. It has a check to check the inside cavities and voids. For example, there's a connecting rod and with a void inside. Now just imagine the repercussion of this, that the weight of the crankshaft can be misleading due to this void, and the costing of it go wrong due to this, and even in terms of mass balancing, it can give a very wrong results. There are some ready checks for checking the discontinuity, G0 discontinuity, point discontinuities. There is a gap in the panel here. This is a body side outer of a panel. There's a gap here, but the designer never noticed it. Nobody noticed it until it got released and came back from the supplier, from the tool maker, that there is a discontinuity here. And then he demanded a re-release of the part, which again takes maybe months to release. Similar like a G1 discontinuity here, there's a sharp line here which should have been smoothened and filleted. It can check that also. Curvature discontinuous, G2 discontinuity, it can check readily. It's a ready check available. Self-intersecting surfaces, solids, it can readily check with a click of a button. Very important, never noticed during the creation of the modeling, but it observes when we try to thick the component and do the object out of it. Instance name, it's a very important when you have a lot of parts inside the product and they are not arranged in the right order. QChecker, within a click, it can create the right order of the component. For example, the part one, the instances have been named one below the other, so we know how many quantities are there, and we have a very clean structure inside the product. Some other checks, like there is a folded surface here, the designer never noticed. However, it came back from the tool maker to suggest that the surface is not correct and the tool cannot be made out of it. This is a ready check available in QChecker. Tangent discontinuity, G1 check, it can check immediately as a ready check. Self-intersecting or wires can be checked. Designer never bothers about it, but it can be checked with the click of check. There can be some datum that are unused. They are not used in, previously the datum used to be like this, but due to new dimensioning or tolerancing methodology or datuming system, the new datuming system came in place and this datum become redundant, but the designer misses to remove it. So even QChecker can check the deactivated or redundant datums, and the designer can then remove it. Another one in FTA, 3D PMI or GDNT, designer can give fake dimension due to release pressure to just meet the release timelines, but it can check it very early in the process. So he's relaxed that yes, we can easily release the component. Um, in the captures also in the 3D PMI or GDNT, it has a ready check like the capture names must match the view names to maintain the sanity, to make the correlations between the two. Very important, very important this is actually. FTA standards, any company can have maybe ASME. A lot of companies choose ASME Y14.5M GDNT standard, but there are some companies in different industries that go for altogether different dimensioning GDNT standard. So you can set your standard and check whether the standard is being followed in annotations or text dimensions and text symbols, etc. This is one of the very common error designer do when they think the component. The join has to be, this arrow should be always pointing toward the material direction. As you see here, these two arrows should be in the same direction, but this care is never taken by designer, and then the thickness goes on the other side and it can create mess if the tool is made out of it. The A side can become B side and the B side can become A side of the component. Uh, there are some checks like there can be just one command below an geometrical set just to maintain the sanity and feature-based modeling approach of the model. That is ready check available in QChecker. Then it's a very simple check like sketch is not fully constrained. QChecker can detect it very early and then is over constrained or under constrained or free that it can check. And then designer can correct it. Yeah. Construction order, it can detect that designer cannot really go for any haphazard modeling methodology. He cannot first fillet the component and then give the draft. It's a wrong method. So it can detect that sequence also very easily. Clash detection is one of the beautiful command or beautiful, very robust check in QChecker that it can check whether it is touching or clashing. No show commands as I shown, it can turn, if you click the healing button, it can turn this mess into very clean model visible to the in the JT files or maybe lightweight applications. Then, as you know, CAD UI it can perform inside QChecker. You don't need to go for CAD utility and do the CAD UI. You can repair all the major checks, intermediate checks, and minor checks inside being into the QChecker application. You can limit maximum part size to maybe 550 MB or 60 MB so that there is a discipline that is followed by the engineers to do the proper CAD modeling when they are modeling the components. You can set the value that your company or organization chooses to, like millimeter. He cannot give dimensions in centimeters or meters. So all it has to be measured in millimeters only. This is very important related to general notes in any drawing. Like any drawing has general notes. Any product has drawing and it has general notes where all of lot of regulations and lot of test parameters, lot of inside company standards are written. So the company chooses to automate that all by the help of CATIA parameters, so that there is a check in QChecker that checks whether the text in the general notes is derived out of a CATIA parameter. So that linkage it can check. Current work object, it is a very useful check. While designing the component, the designer can be inside. It should be technically over the part here as such to show the finished component, but he can be inside the model here somewhere, and that can this data can go wrong if it reaches the supplier or tool maker. So it checks, and there is a healing option available. If QChecker notices it, it can, by the healing operation, it can make the part body current work object. It can check how much character length of a part number or part description you can allow. For example, 1 to 25. So this check allows just 25 character length of the part name nomenclature. So there is a disciplined approach while naming the components. Yeah, with all this, I hope I'm making the context very understandable. So let's check how the Q checker is when it got introduced, how it got applied and invented. So there is a company in Germany, Technia, which is a, a developer of this software in conjunction with Dassault Systems, and it works primarily on the CATIA applications. So it focuses on ensuring the quality of and compliance of CAD data and models, and helps maintain CAD standards, detect early errors, and etc. So in 1990, when they started with very few checks, very minimum number of checks just to validate the application. And then in 2002, a lot of more checks were added, and it was made available for CATIA applications, DeFi applications. In 2006, the standard components to embed QCheck in PDM started, and in 2007, QChecker 2.0 enhanced the interactions with results. The new 2.0 version released. And 2009, it was made available for CATIA V6 to dedicated customer just for checking the primary usage. So this is how the application looks like. This is the usual design window or workbench window inside CATIA. And this is the actual window of the Q checker, how it checks. Now that you will have a demo very shortly with my colleague here. Let's take a worldwide look. It has a presence all over the world. More than 1,500 companies use it at the moment. 1,000 in Europe, 250 in North America, and 250 in Asia. It is used in exhaustively in automotive, aerospace, machinery, and consumer goods. So wherever there is a important data creation, and it has a usage, and it is critical for business success, QChecker makes sense there. These are top 50 global OEMs use QChecker. You will see all big names here, uh, mostly from Europe, North America, India. Not only OEMs, but many suppliers globally use QChecker. They heavily rely on QChecker for data quality, because their quality is checked by the OEMs they work for, and then the pricing and the quotation and etc. is decided, and the trust that OEM shows on the supplier is enhanced due to use of QChecker. You'll see ZF, Stanley, TI Automotive, Johnson Controls, Foratia, all use QCheckers globally. If you talk about India, we have all big names here like Lear Corporation, Gabriel, Ola Electric use it, Tech Mahindra is a user of that. Then Force Motor have it, Quest Global, Kalyani Bharat Forge use it. So it's a big list, and yeah, with that, I finish my session here. I hope this session was interesting, and we made understand the relevance of the product data quality in the business applications, business scenarios, to increase the rather decrease the costs and reduce cost efforts, and uh, uh, increase the quality of the objects, the product quality. Yeah. So with this, I give to Abhay to have. If you have any questions, we can take it now.
Sushil, I think we can hand it over to Nagappa for his demonstration.
Yeah, yeah, and you can make Nagappa presenter so he can share.
Yeah, thank you, Sushil, for the detailed explanation of the PDQ system in conjunction with the CATIA V5. Let me directly take you to the live demonstration so that you'll get the clear picture how it works in the real time. So I'd like to welcome each and all once again. So currently I have opened the CATIA 2020 release. So just okay, along with our CATIA, just it's a small setup installation in conjunction with the CATIA V5. So this is the additional toolbar which is adding after the installation. So for the PDQ system. Let me for the live demonstration, let me go with some small example. So this is a example. This is a model for the rear frame connection part. Okay, here I have created a body along with some operations and the planes and the axis, some the publications elements and the construction elements. With the help of this, I made a small part with a machining part. Okay, we'll see how this FDQ system helpful for in terms of data quality. Let me run FDQ system just by clicking this icon. Okay. So we all know that like every company, every design company, manufacturing company related to the process, when it comes to method, we have a checklist. So we have SOPs. Okay. When it comes to the design CAD data, we have a checklist. So again, it's differ from company to company. Let's say a CAD system. So these are basic steps. This is for one of the OEM. When it comes to the model, again, we have a related to part design. We have a list tab checks that need to be checked for all the parts. Okay, when it comes to assembly, again we have a lot many checks that need to be checked before sending to our senior member, okay, or the one who owning the product. Okay, so this is a list of checklist. When it comes to again, this is a different company example. So we have a checklist for the part, for the product, all these things. So after completion of, we need to do a self review of all the checks whether my model is following, a particular model is following all the checks or not. Again, after completion of self, we need to send it to the final review for the manager or the supervisor or anyone who owning or reviewing it. Okay, at the end, he'll go into the product main product owner. Okay, he'll come with the defects or minor defect, major defect, all the things. Okay, this is like a everyday activity that when you into the process, it's an everyday activity. Okay, we try to eliminate all the modeling errors in a very first stage. Okay, so after clicking this, we have an additional window. Okay, all we need to do here, need to select a proper environment and the profile. So here the environment profile talks about your checks. When it comes to the like every method, every process, every thing will have their own checklist. Okay, here just we are selecting based upon our project. Okay, so the environment may be different. Maybe if you are supplied for the many OEMs, it may be when it comes to the Airbus, when it comes to the Boeing, when it comes to the Olo. Okay, there are many OEM. Again, when it comes to the Airbus, we have many variants as well. Okay, the variant comes like A220, A330, A350, A380. All we need to select a proper checklist for a particular project. Okay, for the live demonstration, I'm selected a small demo environment. Let me run through this. We'll see how it throw the modeling errors related to this particular models. You can see this is the window which is open right after running the secure checker. They end up with the weightage of this much. Okay, can you see this, the permitted elements in a types in no show. So every model, like when you try to send after completion of model, you need to send a model to your supervisor. So only the important things has to be in a show mode. Now we can see the few of the elements which are showing here. You can see this, the planes, the lines, the points, which everything in a show mode. Okay, so how the PDQ system will helpful to eliminate all these things in a shorter time. Okay, just select it. As Sushil sir explained, we have a healing option. No need to go back to the model and rectify it. Just by clicking this. Okay, all the unwanted elements get hidden. It will go back to the hidden mode. Okay, when okay, you can see the sketches. So our sketch should be a fully constrained. Okay, it should not be isochronous or under constrained. It should be a fully constrained. Now it's highlighting like few of the sketches are not fully constrained. You need to rectify it before sending our model to our supervisor. Okay. Along with that, it's highlighting some deactivated features. So these are all our deactivated features. We all know that if the model contain deactivated feature, that leads to a big issue when it comes to the EMOM or MBOM. We may get like the variation of the weight. Okay, we need to rectify our model in very first stage. Okay, we need to eliminate the unwanted features which are associated to our model. Okay, now the VDQ system, that this thing highlighting all these are deactivated feature. With the help of the healing option, we have two options: either you can delete it, the unwanted feature, or you can activate it. Okay, see, this is a model which is associated one to one. Maybe you need to rectify it one by one. Again, when it comes to here, the publication, the model will have a publication as well. Okay, the publication which is generated from our NMG, numerical master geometry, the one like reference element we made our model. Okay, as the check saying the publication name must match publication element. Here you can see this end up with underscore one, but our publication is we don't have any underscore. Okay, you need to rectify it just by with the help of healing option. Just you select this and click the healing option, it will get rectified. You can see the updated value get added. Okay, can you see this, the visualization state of publish element? So all the publish elements should be in a hidden mode. Now you can see the currently it's like it's in show mode. So just select this and hit the healing option. It will go back to the proper state. Okay, now you can see the model. What we seen just before, it's like the model will showing with the points, lines, few the elements along with the surfaces. So with the help of this VDQ, with the help of healing options, so in a very short amount of time, we are rectifying our model. Again, you can see the current work object. See, we all know that only the part body should be in a working object. Okay, because it contains all the rest of the features. Just click just the heal option. Okay, now it's switched to main part body has a working object. Again, go back to the display performance. We all know that the system to system, the display performance are varying. Or also like we used to get the model from our suppliers or the OEM. All our settings should be similar. It should be matched so that we can visualize a proper model. Okay, no need to go back and tools and settings rectify this. With the help of this VDQ system, we're just one click away, you will get the results. Okay, so all get added. So all the settings get added. Okay. Now you can see our model or along with the features, along with the useful element, we also have empty bodies in it. Okay. Anyway, like as Sushil explained, we need to maintain and need to create our model very less size. Okay. If you go with the unwanted empty bodies, leads to the size of the part become bigger. Okay. Leads to complication. Just you can delete it. No need to go back again. As I said in the healing option, just delete. Okay. So can you see this? We have added one more, the joint definition. So it's stating like the merging distance does not match the requirement. Okay, if you want to know the real what exactly the allowable value, just click this particular option. So this is the criteria. So this allowable value is 0.08. So we need to go back, need to rectify. So the allowable value for this particular surface key is 0.08. Okay, once you comes under the allowable value, the checks will be fast. Okay, then we'll go with the only one profile per solid features. When you expand, it will again highlight. No need to like expand the T structure. Just expand it here, select it, and make it a center crop. It will take you to the particular model. Okay, here it's stating like this particular pocket will have more than one feature in a solid. But as per our design standards, it should be only one feature in a one sketch, because it's we are our design, our modeling, our drawing are not limited to our company. We are dealing with the suppliers, we are dealing with our OEMs. Okay, the data which is flowing or which is coming from the supplier all should be in line. Again, if you just send this thing, we may end up with the design changes, some markups. Okay, to avoid that, need to rectify with the help of this particular system. And also you can see the root part name must match the cat part name. You can see here the document which opens, the name is different and the part document name is different. Okay, again it leads to complication. The data once you there in a drive is different, once you open it in a real-time CATIA, that is different. To avoid that complication, just you can rectify this particular thing with help of healing option, so that this one and this one both are matching with the help of healing option. You can see the position 2 3 axis and the position 2 both are matching now. So your document and the the local drive and what you open the CATIA both are matching now. And also we have so after running all these things, so we have filter. Just filter it. What are the corrected things? Okay, in very less time, maybe less than a minute. Okay, you rectified all the your errors which are associated with your model. Now the model is ready to send to your senior supervisor or any downstream applications. Okay, it's not only limited to the outlet detail hiding or showing all those things, and it's also very important. It gives, you need to set your parameter as well. When it comes to adjoin, we have so many options here. Okay, so based upon our facility, our manufacturing facility, we need to work as per our requirement. You need to set, okay, just if you uncheck all these options, if you create your model, that leads to complication. When you send a model to your CA engineer, again he need to rectify all this model. He need to send a lot amount of time to rectify the model. So before that, if you involve, like if your check is involved all these things, it's very easy for the CA engineer to take his direct processes. Okay, directly take to his functional work, what he need to be done. He directly apply the load, he'll get the result. Okay, so it's a one-time activity. So if every designer, it's very design build, I can say. Just by clicking the particular Q icon, okay, it's already only need to select the checks which are related to the process. Okay, just by running it, it gives a result. Just to rectify which are related to your model. So this is related to the one part. I will take you the same example for the product. Can you see this? This is a product. Okay. As this PDQ system not limited to only a few models. It's related to your part body, your product, your drawing, your processes, your sheet metal processes. Okay, and also it's not limited to only one process, one method. You can use it the Q checker for all your different projects, different methods. Okay, as you know that every process involves their own checklist. Okay, create your own checklist for with respect to your different project and run it. As you can see here. Okay, I have created this particular in a PDQ system. I have created multiple environment which are related to different projects. Okay, no, like we all know that we manually going with all this Excel files. It's very difficult through naked eye. It's very difficult to rectify all. Are going with all this is very difficult because it's a everyday task. Maybe it's a human tendency may miss something. Okay, so we have automated tool. With this, we can rectify all our product data quality. Okay. Now just select this and run it. Okay. This how it's throwing the result. Now these two are passed. Okay. And also it's throwing the something, the errors related to this. When you expand this, it's setting 4 entities are violating. What is this? The product component with the deactivated features. See, the component, the product should not involve any deactivated feature. It should be a fully linked each other. When you expand it, okay. Can you see this? So this particular product which is having a deactivated features. Okay, so our PDQ system, we have added checks that checking it should not allow any deactivated features. Just by selecting this, just by clicking the helium machine activate, so all get rectified. You can see all everything get healed. Now you can see before we have the two only passed. Now this one also added. Now here it's highlighting something like product clash. The product clash, again, when you expand it, okay, it gives like between what parts it's clashing with each other. Okay, that again, when you go with this the details hit here, the backend we added between all two components, between loaded component, and so we have mentioned the value which it has to check within a 5 mm, the two with a clash contact clearance. Okay, this how it's checking in the PDQ systems. So this is about your product. When I run it back, not only interactive mode, you can run it in a batch mode as well. So let's say like every company working with a lot, so many products, so many parts. Okay, just by selecting the batch mode, you can run the batch as well. Okay, so for the product, we have an additional option called a batch. Here, all we need to select the either you can single product, other either for the product or for all product. You can select like based upon your requirement. You can select. Now I'm going with the all product and parts. Okay, just by running it. It's running for all the products, which includes product and parts as well. So it's throwing a consolidated result for particular product. If we need to run it again for the individual part, just we need to select and run it one more time. Okay, this is throwing a individual result for each part. And also we have a report generation capability, either in XML, HTML, either in a text file. You can generate your report based upon your required formats. Okay, closing it. So this is about product. I'll take you to the drawing, how it throw the result for the drawing as well. So drawing is very important for everyone when it comes to the manufacturing industry. So drawing a seat which is flowing through the downstream. Okay, let me run for the drawing as well. So through the naked light, it looks fine. Like it contains a detailed view, which we have a 2D components. It contains multiple views, okay, and views, the dimension, and also the nodes and the title block. It's all looks fine, okay. We'll see like how it throws the result when you run a particular system for this particular drawing. Okay. Again, I'm selecting the same demo environment for this drawing as well. Okay. No, through naked eye, it looks fine. So all the views, everything is fine. When you run the queue checker, it's showing the result like this. Okay, here I'm adding multiple checks. Can you see this? The permitted text fonts for all my nodes should be a proper. Okay, here you can see it's not allowing. 98 entries are not validating. Okay, here just by clicking this, it will rectify everything. Okay, just a single click, it will rectify all your 98 entries in one go. You can see this, it's come down to the lower for the green value. Now again, you can see, so all drawings should be locked. It should be perfectly locked. All views should be in hidden mode, but you can see the log, it's showing like all the views are unlocked. So you need to go back and select individually and lock it. Just by selecting this, we have healing options, switch back to a permitted state. Can you see all the result? That's locking everything. So along with this, we have also the dimension, like I have added checks which is related to opaque dimensions. The opaque dimension, you know, all that, like how it leads to a big issue in industry, the opaque dimension. Okay, now all this list of dimensions are associated with the opaque dimensions. It's highlighting everywhere here. Can you see this one, this one, this one? Okay. In a healing option, we have two options. Either you can restore back your value to the original value. Can you see this particular value? This is 398 and this is 136. Okay, we'll see how it works. I'll just go with the restore the value. Now you can see like every engineer trying to round up their values instead of like it's going to be weakness is like he may think like taking a lot amount of time to rectify it. Here's this is trying to round up the value, but the actual value is 135.85. Okay, now you can see it's just moved down to the proper, it's going to this thing corrected check. All these are passed. Okay, now I'll go with all. Still a few of the checks are like violating as per my design standards. Now you can see the empty detail views which are associated with this particular time. Okay, when you expand it, we have this particular 2D components which are empty, even not at all using, it's all empty. Expand again, you can see these all are empty. So again, it's not useful to my drawing, just I'll go with the deleting this particular features. Okay. And also we have this the view outside of the seats. Okay, as we all know that when you create a drawing with a proper template with a title block, all of the view should be within our view frame. Okay, now we can expand it. All these three are violating and which are coming outside of the view frame. Okay, but in healing option, we don't have option to taking back to the view frame. We have only option called delete it. So just it's a need to go back and rectify and place it wherever the relative position. Okay. Again, you can see the non-up-to-date dimension. You expand it, like these two dimensions are not up-to-date stating. Okay, just select it, and if you feel like it's not up-to-date, which is not associated, just delete it. Okay, as we seen, like we have n number of violated criteria when n number of violated checks which are associated with this particular drawing. Just by few clicks, all are in order, which are in like following our design standards. Okay, can you see this? No active view in a particular seat. Okay, what is the seat disappoint to? Okay, no, it's stating like no active seats, you can just delete it. Okay, actually stating, so this particular drawing should not be any active sheet. Once you locked it, it should be inactive. Okay, just clicking this, it will go back to inactive state. Okay, now like apart from this particular check, all are cleared. Okay, it's taking very less time, less than I can say 1 or 2 minutes. Okay, fine. So this how we can run the PDQ system for different products and models. Okay, you can generate the results as well. Okay, you can open the results in a different view modes. So, and as Sushil said, we have an inbuilt 400 plus checks. So this is a checklist of all our 400 checks. Okay. When it comes to the report, we all do have this particular report, a very interactive, very visual report we'll get. Okay, which gives the information what are the things are passed, what are the outcome of the assessment. Okay, this is how we can run a PDQ system for your models. This is all about like a live demonstration of the PDQ system. Maybe I'm handing over to Sushil sir for the Q&A system, Q&A session for this.
Yeah, Abhay, can you make me presenter so I can show my Q&A slide?
Yeah.
Yeah, I hope participants we made the context clear. Now with this the basics of PDQ I explained, I demonstrated few slides, interesting slides, and then Nagappa, my colleague, he shown the real life live demo of how. Yeah, hi, hello. Actually, from my side, we presented both like the basics of product data quality, and my colleague Nagappa live demonstrated how the Q checks are performed very efficiently without any consuming more time. So based on this, I hope the session was interesting, but we would like to, you may have some questions. So you may, I mean, you can shoot your questions and we would like to take up questions with you. Yeah, please.
Thanks, Sushil. We have a couple of questions which you can answer. So the first question is it possible to add a particular or a new check in the existing checks which is already not listed in the criteria?
Good question, I will say. Very, very relevant question. That's the sign of a great designer, I will say, that any intelligent designer can have his own intelligence to build on the check. We checked our partner Technia team, and they are. It's possible to build additional checks on top of the available checks, and it is very much possible, but it has to go
So,
through certain validation at Technia Team Germany, and then it will be
so
implemented.
to
Yeah.
add up to Mr. Sushil inputs, there are a couple of generic checks which are available to which we can tweak with the help of simple coding with
Yeah.
if-else statements and relevant errors and success ratio perspective. With right logical inputs, this check to some extent can be created within QChecker also. So that needs a small customization from our end. And
Yeah.
down the line for remaining really in-depth checks needed. So we study the business impact of the same. We study the entire business impact, how this check is going to affect you entirely during your entire design lifecycle process. Then accordingly with the inputs from your end and the understanding of impact, we give it to our principal OEM of the software, and then they develop based on the global understanding, they develop the check in the coming releases. That's the
Yeah.
life
Very
cycle of
much.
need, and that's how the software is
Yeah.
also getting year on year equipped with more and more checks.
Yeah.
There's a follow-up question for the same. So the
Okay.
customer is asking, can we create our custom checklists accordingly?
Yes, in fact, that's the beauty of QChecker. The way a lot of OEMs have their custom built check profiles for your own quality guidelines. We can support you down the line to create your own check profiles So you might be having, as per your own quality guidelines, some checklist in Excel sheet that you might be doing it manually. So these all checks, we can study them, and we can make a check profile for you. I feel I answered it
Sure,
rightly.
sir. There's one more question. So, will QChecker work for all versions of CATIA v5, specifically for the older version?
Yeah, in fact, that's a very old, good question. In fact, though, this is a very old solution. Almost from 2005-6, we are partnered with Transcat, earlier named as Transcat, and for old releases from release 10 onwards, there is association with Dassault System for this particular development of QChecker. So yes, to answer you, from release 10 onwards, we have been associated with Technia and Dassault solution. So all the checks or releases of from release 10 onwards, they are checks can be done with the help of Technia QChecker.
So, there's one more. Is QChecker available for the 3D Experience platform?
Yeah, absolutely. Very good question. QChecker is absolutely is available for 3D Experience, all the latest releases. Today, at present, we have latest release called 2023X. So for that also, on premise as well as on cloud, both the versions of 3D Experience flavors on premise and on cloud, QChecker is applicable for both of them.
Sure, sir. I think that's all the questions we have so far. So I think we can move on to the next slide, Sushil.
Yeah, I think that's it from our side. We have Abhay, who leads marketing function here, and myself, Sushil, from the technical side. These are our numbers showing here. So for any future,
Sorry, Sushil. I'll just like to add one thing.
Yeah.
So, I mean, firstly, I would like to thank you and Nagappa and Chandrakant sir as well for giving us a very informative webinar. I'm pretty confident that the audience who have attended today would greatly benefit from this, and they would surely look for the improving the product data quality in their systems as well. So I would like to also thank the audience for taking their time out and joining us for this session. So if anyone has any further queries related to the subject matter or any other requirements from our end, you can always connect with us. So as Sushil told, our contacts are displayed on your screen right now. So you can always reach out to us anytime, and we'll be happy to address your queries. I would like to also tell you that we do have a feedback form coming up once you end this webinar. So your feedback would be invaluable for us, and it would help us in improving our engagements in the future. So I would like to request the audience that once you get the feedback form, you can fill the feedback form, and you can update the same so that it will help us for plan for our future sessions. So I would like to thank once again Mr. Sushil, Mr. Nagappa, and Chandrakant sir for giving us this webinar. And I would like to thank the audience as well. Thank you once again. See you at the next session.
Thank you, Abhay.
Thank you.
Thank you all.
Yeah.
Have a
Thank you.
nice
Thank
day.
you all for
Thank
the
you.
time for time to attend this session. If you have any open questions, just reach us. We're already ready to have one-to-one session related to our FDQ system.
Sure. Thank you. Thank you,
Thank you
everyone.
all.
Thank you.